Lesson 5.4. Sum and difference identities is what this lesson is mostly about. Here we have that. It says we have some sum identities here for cosine. This is just a Greek symbol for a and b, sine a plus b, tangent a plus. Here's what this is doing. This is taking basically to find cosine, sine, and tangent values by hand that are not unit circle values. For example, that are not values that 30, 60, 45 degrees, 90 degrees, or any of those hand trick values. This should find something else. For example, we could say if I wanted to find the sine of 75 degrees. Well, sine of 75 right now, we don't have any. I'm sorry, let's say 75. There you go. Sine of 75. We don't have a hand trick for that one. How would I do that by hand? Well, this is saying if you could break it down into two angles, I'll write it here, A plus B, then you could use this formula here. So you would say that sine 75 is the same thing as sine of, what's another way of getting to 75 that are using hand trick values? Well, we could say 30 degrees plus 45 degrees. That these two things are the same. You just treat this as angle A, this is angle B, and you would plug it in here. And so you'd say that sine of 75 degrees, which would be 30 plus 45, is the same thing as sine of 30 times the cosine of 45 degrees plus cosine of the 30 times sine of the 45. You just substitute where this is A and B. And we have difference. So if you wanted to find, say, sine of 15 degrees, you could rewrite this as saying that's the same thing as sine of, what's a value that gives you 15? What about 45 degrees minus 30 degrees? And you would plug it in and solve it just like that. That's kind of the idea here. So let's look at example 1a. Find the exact value of cosine 75. And I'm going to use hand trick value. So again, we could get to 75 by saying that is the same thing as 30 degrees plus 45 degrees equals 75 degrees. So I'm going to use cosine's formula. Now you can use the unit circle, the formula chart here. I'll open that up. And if you look down underneath the identities, you have sum and difference, and it has the cosines and the sines here. And you could use that formula, or you could look back here on this page, and it says that cosine of A plus B is the same thing as cosine A times cosine B minus sine A sine B. Now here's a little trick to help you out. It's that cosine's symbol here, the sine, changes. Cosine with a C changes. It becomes a minus. Sines stays the same. That's true with a difference identity. Cosines changes, so the minus becomes a plus. Sine stays the same. All right? So cosine is going to be cos A, cos B minus sine A, sine B. So I'll come back over here, and I'll say that cosine of 30 degrees plus 45 degrees is going to equal cosine of A. So again, this is going to be our A, this is our B. So cosine of 30 degrees, times cosine of 45 degrees. And cosine symbol changes, cosine changes. So minus sine 30 degrees, sine 45 degrees. And we'll simplify each of these. These are all first quadrant, so they should be positive values them in themselves. I'm going to use hand trick. So 30 degrees is the ring finger. If I'm looking at the palm of my hand, I bend my ring finger and I flip my hand over because psi y cos x, tangent is y over x, because x is second. It's the lower, it's the bottom fingers, which are 3 fingers. So it'd be square root of 3 over 2 times, because h is always 2. Remember, you have 4 total fingers. The square root of 4 is 2. Cosine of 45, looking at the palm of my hand, I bend my middle finger, flip my hand. I have 2 fingers below the bend, so it'd be square root of 2 over 2. And we're going to subtract here. Let's see, sine of 30, again, that was ring finger, flip it. I have 1 finger on top for y's, so it's square root of 1, times sine of 45, that's the middle finger, bend it, flip it. I got 2 fingers on top. There's our values. Now I just simplify here. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Here, square root of 1 times square root of 2 is square root of 2 all over 4. Since I have a common denominator, I can reduce this and say this is square root of 6 minus square root of 2 all over 4. You cannot simplify that to square root of 4. That would be incorrect, but I can write it that way. This should be my answer. And I'll check it real quick. If I come over to my calculator, I'm going to press menu, calculator. Let's find out the cosine of 75 degrees. Press the degree button here. Press enter. Let's see if that's the same thing as square root 6 minus square root 2 all over 4. Let's check it. Yes, the values are the same. We did this one correctly. And now let's try part B. Find the exact value of tangent 11 pi over 12. Now this throws off a lot of people, the radians, because they don't know what do I do with here? Do I choose 10 pi plus 1 pi over 12? Well, how do I do this? Here's the way. You're going to choose two values that can be reduced. For example, if I said 10 pi over 12 plus pi over 12, this one it does equal 11 pi over 12, but this will not work for us because though this reduces, this fraction does not reduce. So you have to pick two values that can reduce. How about 8 pi over 12 plus 3 pi over 12? Will both of those reduce? Yes, they will. So this will work for tangent. So I'm going to say that we're looking for tangent of 8 pi over 12 plus 3 pi over 12. Now this formula is not on the formula chart. So we're going to have to come back over here and look for tangent. Here's the one with addition. You remember how tangent is y over x or sine over cosine? Sine symbol stays the same, so in the top it's going to stay the same. So it'll be tangent A plus tangent B. The bottom, it'll change. The plus becomes a minus. It'll be 1 minus tangent A times tangent B. So that's what I'm looking at here. So I'm going to write it out as this equals tangent of A, tangent of 8 pi over 12. It's on the top, so this is like sine, so it'll stay the same, plus sine of 3 pi over 12. All this divided by, the bottom's like cosine, so the symbol changes. 1 tangent 8 pi over 12 times tangent of 3 pi over 12. Did I write sine up top? I'm sorry, this should be a tangent right there. Let's correct that. That is ridiculous. Okay, so it's tangent A plus tangent B over 1 minus tangent A times tangent B. Now, don't forget, this is not first quadrant. This is past half a pi. This is second quadrant. And in the second quadrant, according to our saying, all students take calculus. Because the y is positive and the x is negative, when you get over here, tangent is going to be negative. This value here is going to be a negative value. And so this one is also a negative value. These two are negative. Negative values, since I'll just do Q2 for quadrant 2. It's over here. It's negative. All right, now these are first quadrants because they're below, they're before we get to half a pi. All right, so let's reduce these. Pi over 12. This reduces to become, let's think about this. I didn't even reduce this. This is going to be tangent 8 pi over 12. 4 goes into both, so that's 2 pi over 3 plus tangent. This one simplifies to become pi over 4. It would have been quicker if I did this the first time. All over 1 minus tangent of 2 pi over 3 times tangent of pi over 4. Again, that's almost 1 whole pi, so it's a second quadrant. All right, so let's reduce these. Again, this is the negative value here. And here, those are the negative values. All right, let's reduce these. Tangent of 2 pi over 3. I'm going to take my pi over 3 finger, which is my pointer finger, and I bend it and I flip it. So I'm looking at 3 fingers on top, 1 below. That means it's a square root of 3 over square root of 1, and this is negative. All right, and now I add over here, and this is going to be below 1 and the same value. Negative square root of 3 over square root of 1. And then pi over 4, that's the middle finger. You take a bend and flip it. I have square root of 2 over square root of 2. And this is a positive value since it's in the first quadrant. All right, and now I reduce this one more time. And let's see here. This is just going to become, that's a 1 in the denominator. That's going to go away, as well as this is going to become 1. This will become 1, and when you're multiplying, that won't matter there. That goes away. So let's see here. We have negative square root of 3 plus 1 over, this becomes 1. These two negatives cancel out. So it's 1 plus square root of 3, and it'll be just the square root of 3, which I'm going to rewrite that and say that that is equal to 1 minus square root of 3 over 1 plus square root of 3. Now, I think that's my answer, but we've done a lot of work here. Let's check it and make sure that that is, in fact, correct. So the way to check it is we'll go over here, trig, tangent. We have 11 pi, which will divide over 12. I want to make sure I'm in radians mode so I don't mess up. You could, it says degree right there, so I'm not, but if I press the pi button, I just click the R next to pi like that. When I press enter, there's my value. So let's see if, in fact, our answer measure is correct. 1 minus square root of 3 over 1 plus square root 3. Whoops, that's the 3. Yep, it's correct. So we did do it right. Now, one thing we could do here is, again, though this would be acceptable on AP Calculus, the truth is you're not supposed to leave it like that. So if I wanted to rationalize the denominator, what I would do here is I would multiply by the conjugate. So I have right now 1 plus the square root of 3 in the bottom. If I just multiplied that by 1 minus the square root of 3, here, by multiplying by the conjugate, I could, 1 minus square root of 3. Technically, what I'm doing here is I'm multiplying by 1. What I can do is I can eliminate that square root in the denominator, the radical, because when you multiply with conjugates, what happens is the middle two terms, that when you FOIL here, the O and the I cancel each other out. So all I'm left with on the bottom would be 1. The 1 times negative square root of 3 and the positive square root of 3 times 1 would cancel. So let's go away, and then square root of 3 times negative square root of 3 is negative 3. That's your denominator. For the numerator, I would FOIL this out, and for the sake of time, I'm going to just go 1. This second term, the O and the I would match each other, so it would be negative 2 square root of 3. And then again, negative 3 times negative square root of 3 is going to be positive 3. I can simplify this and get 1 plus 3 up top is 4 minus 2 square roots of 3 over 1 minus 3 is negative 2. If you break those apart and simplify them, 4, sorry, that's ugly, 4 divided by negative 2 minus 2 square roots of 3 over a negative 2. And finally, that leaves us with negative 2 here. This becomes positive. These two cancel each other out, and those go away, so it'd be square root of 3. Let's check that answer. Negative 2 plus square root 3. Why am I not getting that 3 in there? 3. Enter. Yep, that matches. So that's how we did it correctly.